Number 3. The surface area of a hot air balloon A in meters squared filled with hot air is given by the function AR equals 4 pi r squared, where r is the radius of the balloon in meter. The radius of the balloon is increasing as a function of time in second, according to the formula RT equals 2 over 3 t cube. T is more or equals to 0. Okay, so 3A, state the surface area of the balloon as a function of time. State the surface area of the balloon A as a function of time. So this is composite. Okay, so we have two formulas here. AR, area, in term of r is 4 pi r squared. And then radius in term of time is 2 over 3 t to the power of cube. So the surface area of the balloon A as a function of time is AR to the power of t. AR or ART actually. Okay. So you have to substitute the RT to inside of AR. Okay, so where do you have to substitute? So you have to substitute this inside AR where R is. Okay, so this is function of R. This is something like let's say you R equal to something, so you replace this with R is. Okay, so it become 4 pi. The R you place with 2 over 3 t cube, and here is R squared. Okay, so simplify, so it becomes 4 pi 2 over 3 pi cube is 2 over 3 squared also, so it becomes 4 over 9 t to the power of 6, because 3 times 2. Okay, then multiply 4 times 4 becomes 16 over 9 pi t to the power of 6. Okay, that's all for A. For B, find the surface area of the balloon after 2 seconds. Okay, you just replace the value of, okay, the value of t as 2 in this case. Okay, so AR, area, in term of t equals to 16 over 9 pi, and then replace t as 2 to the power of 6. So you get just press calculator, 16 over 9 times 2 to the power of 6, then you will get 113 7 over 9 pi m squared. Okay. Okay, number 4. A cylindrical container of radius 20 centimeter contains 200 centimeter cube of water. The container is filled with water at a constant rate of 100 centimeter cube per second. A. Write the formula of A1, the amount of water in the container. V, after t second. Okay, so the container already has 200 centimeter cube of water, and then it is filled with water at a constant rate of 100. So for A1, it will be V equals to, or V in term of T equals to 200 plus 100 T. Okay, how did I get this? It's already have 200, so 200 plus 100 times T, because if T equals to 1 times 100, then you can calculate the volume of water. Okay, then A2, the height of water in the container H in term of V. This is according to this formula. So actually we know also that in order to calculate volume of water in the container is V equals pi r squared H. Okay, and so what we have to do, because the height of the container in terms of V, so you just move pi r squared to the other side, so V over pi r squared equals H. Alright, so that's all for A2. For A3, the composite function. The composite function HVT, that is substitute VT inside HR. So write down again. Okay, you have already VT, and then the one that we have for A2 we didn't write in terms of the function. Function of HR equals to V over pi r squared. Okay. So for A3, HVT, okay, you replace VT inside H. Okay, so you place this inside here where V is. So HV, so V replaced with 200 plus 100 T over pi r squared. And we already know that the value of R is 20. Radius is 20. Replace. So 200 plus 100 T over. Okay, HVT equals to 200 plus 100 T over 400 pi. Okay, so after that we simplify, factorize the top. 100 2 plus T over 400 pi. We cut 100 over 400. So the answer will become 2 plus T over 4 pi. Okay, that's all for the function. And then find the height of the water in the container after 20 seconds. So the value of T will be 20. Okay, so for B, we just replace T as 20. So HV 20 equals to 2 plus 20 over 4 pi. So pi replace 3.142. So it becomes 22 over 4 times 3.142. I cut 11 and 2. So it's 11 over 6.284. Okay, then press calculator. 11 divided by 6.284. So the answer would be around 1.75 centimeter. Okay, 1.750 something. Okay, Okay, that's all for question number 4. Okay, number 5. A small stone is thrown into a calm pond and produces a circular ripple. The radius of the ripple r in centimeter is increasing at a rate of 3 centimeter per second. Find the expression for the radius r in terms of time t after the stone is thrown. Because the radius of the ripple is increasing at the rate of 3 centimeter per second, so it depends on the time. So the expression will be r according t equals to 3t. Okay, so if t equals to 1, so we welcome 3. If t is 2, so it enlarges to 6. Okay, so that is question A. B. If A is the area of the ripple, explain the meaning of the composite function A R T. Anyway, so A is area of the ripple because the ripple is circular, so it's pi r squared. Okay, so ART is the composite function. Okay, replacing RT inside AR, RT inside A. So this is in terms of R. So you just replace 3t where R is. So pi 3t squared. So it become 9t squared pi. Okay. Oh, so what is the meaning? The meaning is area of the circle will be affected by the radius. The radius is affected by the time. Okay, so in other words, area of the circle, area of the circle is a function of time. Okay, and then okay, so and find the area of the ripple after 30 seconds. Okay, since I've done the composite, I just replace t as 30. So for C AR, the time is given as 30, so just replace 930 squared pi. So if it is in term of pi, it should be 30 squared mean 900 times 9 would be 8100 pi. Okay, I just simplify like that.